Correct? Yes or no? Okay. Followed by, I said to do 5F, right? I think 5F shouldn't be a problem, huh? It's the LCM. Okay, good. Then 7B, correct? It is also LCM and there shouldn't be any problem as well. Number 8 is find the smallest non-zero whole number that is divisible by this. This is also LCM, I told you yesterday. This one shouldn't have problem as well, right? I will start from question 9. Will that be okay? Alright? If you can do, of course, we go quick as revision. If you cannot do, then you have to listen carefully. Understand? Okay, now let's take a look at question number 9. The number has exactly 8 factors. I think let's say I have a number 8. I have 8 factors. And 2 of the factors are what? 10 and what? 1, 2, 5, right? Correct now? This is the question, right? So they say list all the factors of this particular number. Okay? Right. First of all, 10 is 2 times 5, okay? Yes or no? What about 1, 2, 5? Yes. What's 1, 2, 5? 5 to the power of 3, right? So, factors of the number will be, those are done. You will know that it's first of all 1, right? Correct. Then what is it? Can be 2, yes. Next one is what? 5. Good. Then 10. Then 25. Then 1. 25. What else? Huh? 50. Good. Some more. 1, 2, 5. 250. Now we check, 250, 2005 is 250, 250, 250, right? Then we count how many factors? 1, 2, 3, 4, 5, 6, 7, 8. Can you see? This is exactly the same as the example that I was given the other day. Am I right to say that? So are you all okay? Are you all okay? How many of you can do this one? Good. So you all must try, understand? Must try, okay? Now, next one will be your question 11. Let's look at question 11. Find the smallest value of k such that the LCM of k and 6 is 16. So the LCM is actually 16, right? Correct now? Okay. Now, we all know that 6 is what? 2 times 3. Very good. Now, 16. If I write it in prime factors, what should it be? 2 what? Square times 3 times 5. Is it correct? Is this correct? Now, remember I said this one is what? Work what? Backwards, right? Okay. Now, it must be 2 to the power of 2. So, this one must be what? 2 to the power of 2, right? Do you all agree with me? Okay, this one must be 2 to the power of 2. Then 3. 3, this one already have, so no need, right? So what should the next one be? 5, right? Do you agree? Can you see that when I look at this, the LCM will be 2 square, 3 and 5, right? So what will be my k? 2 square times 5. Answer? 20. Are we all clear? I'm explaining to you so that you are clear. Now, why am I saying this? Because O-level like to set this down questions. When I teach you, I'm not just teaching for Sec 1. I'm teaching for O-levels. Is that clear to everyone? Okay. So, this is your question number 11. Okay, which is 20. I'm not worried about the answer. I'm worried about the process of getting the answer. Are you okay? Yes, because you know what? Exam, I will not be there telling you how to do it. So you must repeat this process of thinking and how to get. Everybody clear? Okay? Alright, good. So that's your 11. Next, we move on to 13. Would that be okay? How many of you cannot do 13? Okay, just 13. Let's do 13. Let's do 13. The numbers 1080, 1188, and 1815 written as the product of their prime factors are such and such. Okay, so I will have 1080 as 2 cubed times 3 cubed times 5. 1188 as what? 2 squared times 3 cubed times 11. And 1815 as 3 times 5 times 11 squared. Now, can you see this is a very kind question? Why is it very kind? 50 for you already, ma. Then I need to tell you this. In maths, right, especially secondary school, when they use the word hence, means you must use the question or the previous part that you have solved to answer it. Okay? Hence means you must use the previous part. That means they given you this, you must use this. Don't even use another method. Understand what I'm talking about? Now, if the question says hence or otherwise, that means you can use another method. You need to give what they given you or the previous method. Are you clear with what I'm saying? So once you see the word hence, that means you must use the previous part of the question. Okay. Now, question 13. Let's take a look. What did they say? Hence find the greatest whole number that will divide this, and this. My question to you is this. I want to know whether it's HCF or LCM. HCF, right? Do you agree it's the HCF? Okay, alright. So, HCF. Okay, oh no, what do I take? Can I take 2? No, what can I take? 3. Then? And nothing. Do you agree this is the best number already? This is the highest common factor. Are we clear? So it looks very complicated, but actually it's only 3. You must know how to see out the answer. Am I right to say that? So that is your question 13, and the answer is 3. Now, what if I ask for LCM? That is going to be terrible, right? Can you see there's a lot? Okay? Okay, go to LCM, we just do verbally. What the LCM, what do I have? 2 cubed, right? Then 3 cubed, then 5, and then 11 squared. So we have a big number. Understand what I'm talking about? Okay? So this is actually testing your concept, whether you know what you're doing or not. Understand? It's the highest common factor question. Okay? Can you see whenever I choose question, I choose a variety of questions how they ask, so that you are exposed to it. You don't be so surprised, oh, I don't know. Huh? Okay, so this is number 13. Next one, number 15. 1120 is 2 to the power 5 times 5 times 7. 1276 is 22 times 11 times 29. And 1450 is 2 times 5 squared times 29. They say, hence, find the smallest non-zero whole number that is divisible by this. That means that number, when divided by this or this must be a whole number, right? So am I looking for HCF or LCM? Good, LCM. Now, can you see this one is a bit our child? Can we get 2 or not? Okay, 2 power what? 5, good. Then 5 power 2, then 7, good. Then 11, then 29. Now this is in index notation. Key in your calculator. What is the LCM? One, 7, 8, 6, 4, 0, 0. How do we read this? 1,786,400. Are we okay now? Are we okay here? Can or cannot? Can, huh? I just want to know, can you differentiate between highest common factor and lowest common multiple? The type of question. Can, huh? No problem. So this is 15. Very good. Next. Next will be question number 18. Is that correct? Question number 18. Okay, let's take a look at question number 18. The highest common factor of two numbers is 175. The lowest common multiple of these two numbers are 12600. Both numbers are greater than their highest common factor. That means it's greater than what? 175. Agree? Okay? So, find the two numbers. So, 18. Now, usually I don't like find the numbers very confusing, right? I let it be number A, number B now. And then it be P or Q or whatever it is. Okay? Now, the HCF is what? 175. What is this in prime factors? 5 squared times 7. Is this correct? Is this correct? Okay. What is the LCM? 12600. What is this in prime factors? 2 power? 3. 3 power? 2. 5 power 2. No more. And what? Just 7. Is that correct? Better check out. Now, even if exam you don't know how to do this, put them in prime factors for some marks on. Don't say totally don't do. Understand what I'm talking about? Okay? Alright. Now, let's take a look at this question now. How are we going to do this? Now, highest common factor is this. That means both also must have this now. You agree with me or not? So, both also must have. Agree? Alright now. So, I settle already, right? Correct? Okay. That means these two are also settled already. Can you see? So, what do I have left? 2 cube, right? I can have times 2 cube, then times what? 3 square, right? Agree what I'm saying? So, times 2 cube times 3 square. Can you see that? So, what is A? Can you see this for me? 1400. Is this correct? Is this 1400? Okay, how about B? How about B? 1575. Are we okay? Can you see how to work backwards? Okay. So what's the first thing you do? You take the highest common factor and put there first. Correct? Because it must be common to both now. Right? Then you fill in the blanks for the rest. Are you okay? Okay? Okay, so this is your question 18. Alright. Question 20. Let's look at question 20. Okay? Now I'm doing all this is not because I'm mad or something like that. Because I want to know you must present properly. You cannot just write numbers for fun and then don't write anything else. Understand? Oh? Now let's look at question number 20. Chauffeur needs to pack 171 pens, 63 pencils and 27 erasers equally into identical gift bags. Find the largest number of gift bags that can be packed. This one is something like, remember yesterday I said the roses, the tulips and the orchids. Can you see? Okay, what's the first number? 171 pens. 63 what? 63 pencils and 27 erasers. Alright? Okay. You do the prompt factorization, I'm not going to do for you. What is 171 in prompt factorization? No prompt factorization. 3 square times what? Times what? Times 29. Times 19. Okay. Is this correct? 63 times 7. Very good. 27. 3 cube, right? Okay, now, how many gift bags do I have? Will be what? HCF or LCM? HCF, okay. So, top one. HCF will be what? HCF, let's take a look. What will it be? 3 to the power of 2, right? So it's how much? 9. Correct? So I will have 9, you must answer 9 what? 9 gift bags, correct? Okay. Part 2, what did they say? The number of each item in a gift bag. That means I can pack to 9 bags, right? Okay. In one bag, there are, now, how many pens? Can you see this is already 9? So how many pens? 19, right? Okay. 19 pens. How many pencils? It's already 9. So how many? 7. Okay. How many erasers? 3. Very good. Are we clear? Are we clear? You say each item. Now, what if I say, what is the total number of items in each bag? And what should I do? I must add up on this side. So it becomes what? 29. Are you all clear? So you must read the question carefully. You cannot just blindly do the question. Everybody clear? Can or cannot? Can. So question 20, the answer is 9 and then 19, 7 and 3. Are you okay? Are you okay? Alright, good. Last question, 22. I think some people have problem with this. How many have problem with this? 22. All can do? Who cannot do? Hands up. Or I'll start. It's okay one, no need to be shy. Start, we start. Okay, I will do this one. Because this one is actually a bit of thinking. Okay. 20, cannot remember. 22. Okay. All of you listen to me, those who cannot do especially listen to me. 2 race cars, car X and car Y, are at the starting point of a 2-kilometer track at the same time. Car X and car Y make 1 lap every 60 seconds and every 80 seconds respectively. 1 lap means what? That means they go one circle like that. Understand? 1 lap, 2 lap, 3 lap, 4 lap. Understand? Okay, so car X take how long to make 1 lap? 60 seconds, right? Correct? How about car Y? 80 seconds. Now, with this information, can you tell me which car is faster? Which car is faster? X, right? Because 60 seconds can go around already. Everybody clear with what I'm saying? Okay, Alright. Now, first of all, let us put 60 into prime factors first. So 60 is actually 2 squared times 3 times 5. Okay? Those who have done it, we have this one. What about 80? Okay, now then the question says this. How long in seconds will it take for both cars to be back at the starting point at the same time? Do you agree I must find the LCM? Correct, LCM. Okay, so LCM will be 2 to the power of 4 times what? 3 times 5. So what is this timing? 240 seconds. Very good. many rounds? Round takes 60 seconds. How many? 4, right? 4 rounds. How about car line? 3 rounds, right? Alright? That means in 240 seconds, car X is 1 lap in front of car Y. Do you agree with what I'm talking about? Okay, now. Write down this. Agree with this statement? Okay? Agree with this statement? Okay, now the next question. How long in minutes will it take for the faster car to be 5 laps ahead of the slower car? Now, can you see that to be 1 lap, I need 240 seconds. Okay, so 1 lap is 240 seconds. You cannot put equal, this arrow sign represent. How about 5 laps? 240 times 5. How many seconds is this? 1, 2, 0, 0. Very good. 1, 2, 0, 0 seconds. A lot of people will stop here. But what did the question say? Give the answer in what? Minutes. What do I do if I change it to minutes? Divide by what? 60. So what should it be? Huh? 20 minutes. Are we clear? Are we clear? Okay, now I try to be as clear as possible already, so that when you revise for your WA is okay. Later I'll tell you more about the WA. Would that be okay? Can or cannot? Cannot? Are we okay with the foolscap paper? Okay, if you have used more than one piece, can you staple them together? Okay, I'm going on to the notebook questions. I'm going on to the notebook questions. Okay? Keep your foolscap paper first. Later on, then fast forward. I want to look at the notebook questions. Okay. Now, actually, do you agree that 21 and 23 are actually quite simple? Do you agree with me? They're actually quite simple. Let's look at 21. Sweets are sold in packs of 120, while mini chocolates are sold in packs of 18. Okay? Cindy bought the same number of sweets as mini chocolate bars. Find the least number of packs of sweets that she could have bought. Okay? Now, sweets are sold in packs of 120, whereas mini chocolate bars are sold in packs of 18, right? Cindy bought the same number of sweets as mini chocolate bars. Find the least number of packs of sweets that she could have bought. Okay. I want to know, okay, this is number 21. What do I look for? Highest common factor or lowest common multiple? Huh? LCM, right? Do you agree it's LCM? No, you see, you look at the question first. Sweets are sold in packs of 120. That means, if I want buy one packet of sweets, right, there's 120 inside. Okay, then what about the number of mini chocolate bars? I buy one packet, I have 80, right? Okay, what did the question say? Cindy bought the same number of sweets as mini chocolate bars. That means the number of sweets must be the same as the number of chocolate bars, you know. Alright now. So it must be finding the LCM, right? Agree class? Okay now. 120, what is your prime factorization? 2 what? 2 power? 2 power what? 3 times what? 3 times what? 5. Good. 18 is just 2 times 3 square, right? Alright. So what is the LCM? 2Q times 3 squared times 5, right? So what should this be? 1, 1, 2, 1, 5. Is this correct? Is this 1, 2, 1, 5? Wait, I'm talking to you. Let me calculate out. I want to double check. Okay. 360, right? Aiyo, how can be so much? 360, right? Alright. Alright. That means how many packets of sweets must you buy? We get 360. Okay. Number of packets of sweets will be 360 divided by 120. Answer 3, right? You must buy 3 packets, right? Then you get 360, right? Now, what if I extend the question? What about the number of packets of chocolates? I will take 360 divided by what? 80. How many packs? How many packs? 20? Is it 20? Talking to the class? Is it 20? Yes. Okay. Now, can you see that when I buy 3 packets, I'll get 360. When I buy 20, I'll get 360. Understand now? This is what I mean by equal number of sweets and mini bar chocolates. Are you okay now? Are you okay now? Okay? Okay, Alright, so question 21 will be 3. Because they only want this. This is actually an extension for you. Alright, what if they want the number of packets of mini chocolate bars? Everybody okay? Everybody okay? Yeah, Alright, now, last one. Question 23. That is in your notebook. Let's take a look at question 23. What did he say? Kumar wishes to cut the biggest possible squares from a rectangular sheet of paper without any leftover paper. The sheet of paper has a length of 65 cm, okay, and a breadth of 50 cm. That means I have a piece of paper. This is 65 cm. This is 50 cm. Well, I want to cut squares. I don't know how many such that is exactly. That means I'm finding what? Highest common factor. The B plus. Okay, 65. What should it be? What's your rough factorization? 5 times 30. Okay, very good. How about 50? 2 times 9 square, right? What is the highest common factor? 5, right? Everybody can see? 5, right? Then we look at the question now. Part 1. What is the length of each square? So what's the length of each square? Yes. Length of each square must be a 5 cm, right? Everybody okay? Okay? Okay, then they say, how many squares can he cut all together? Now, 65, 5, I will have 13 here, right? Do you agree I will have 13 here? So, 13 times. If it's 5 here, I will have 10 here, right? 10 on this side. So, how many squares altogether? 130. I just want to know, are you all clear so far? 10 or 10 up? 10 or 10 up? Better take this down because all these are important. Okay? Alright, now, I want to summarize what we have done in this chapter 1. So, first of all, we have done is we have done index notation, right? That's the first thing, index notation, correct? Then we've done something called what? Yes, prime factorization. And before we can do prime factorization, we must know what is a prime number. Alright? Prime number can only have two factors, 1 and itself. What is the smallest prime number? 2. Understand? Okay. Then we know how to find highest common factor and lowest common multiple. And then we also know how to do problems that have highest common factor and lowest common multiple. Okay? Can or cannot? Plus. Can or cannot? Cannot. Okay. Now, your WA1 will be in week 7, 14th of February. Okay. Which chapters? Chapter 1 and chapter 2. Next, I must finish chapter 2 by then. Okay. Now, for express students like y'all, okay, I will not do revision. You've got to revise yourself. Because anyway, you have my video to go home and revise. Do you understand? And how to do revision? Like primary school, do paper, but you don't understand. You must understand and you do. Understand? Go and look through all the homework that I've given again, and look through all the notebook questions that I've given again, so that you can know what is happening. Are we clear? Oh, I missed out one thing. We also did something called square root and cube root. Remember? Square root is how many take out 1? Square root is how many take out 1? 2 times, right? Cube root is what? 3 times. Remember? Okay, then we say we divide the power by 2 and divide the power by 3. Are we okay? Can we remember that? Okay, good. Then can we pass forward the full step paper? Just give it to me, you'll do. What you're doing? Why are you crowding around there? Just have to give me and that's all. The rest sit down. Okay. Jay and Zhu Qing is not there, so I should have 28. Am I right to say that? Alright, now I will want to check your file with your filing when I finish chapter 2. Understand? Because now I collect no use, only one piece of paper inside. Understand? I will check your file once I finish chapter 2. Are we clear? Okay? Alright. So, have you taken this down already? About your WA1? I'll remind you again. Okay? Who can tell Zhu Qing for me? Okay? Who can tell J for me? Nobody can tell J for me. So putting. Huh? So putting J. 106.
J never give us his number.
Huh?
J never give us his number.
J never what?
Give us his number.
Oh, never give you his number. But you should be looking at my video, right? I suppose that.
Oh no, I'll just email him.
Never mind. I'll remind you again nearer the time. Okay? Nobody has J's number. Okay. Okay, now. Alright? So we are irrational numbers and real numbers. Now don't be too frightened about all this first. Okay? First of all, I want to talk about integers first. All of you look at the board now. What are integers? Okay, it's just a name. Okay, all of you look up here. We have something that is called a number line. Okay, this is 0. 1, 2, 3, 4, 5. These are the number. -1, -2, -3, -4, -5. Now, number line need not always be horizontal. It can also be what? Vertical. Now, if I have a vertical number line, it will be 0, 1, 2, 3, then -1, -2, -3. Understand? Can or cannot? Okay, now, all these numbers that are whole numbers, they are called integers. It can be positive, it can be negative. It can also be 0. All these are called integers. Now, if I have, this is not an integer because it's not the whole number. Understand? For example, if I have like that, also not an integer because it must be a negative of the whole number. Everybody clear? Okay, now, this side is called positive integers. This side will be called negative integers. What do you think is 0? 0 can be positive or negative. If I plus 0, you still remain the same. If I minus 0, you still remain the same. 0 is actually neutral. Can you take down this diagram? Okay. On page 32 or 33, any blank space, just take it down. Okay, I want you to know what are positive integers, what are negative integers, and what is a neutral integer. Alright, let's take a look at page 32. In primary school, we have learned about whole numbers, decimals, and fractions. Okay? These numbers are greater than or equal to 0. Numbers that are greater than 0 are called positive numbers. Understand? Positive numbers. But if it is this kind of whole number is called positive integers. Understand? Now, what do we mean by that? What's the difference between positive numbers and positive integers? For example, I have a 1.5. This is a positive number, but it is not a positive integer. Understand? For example, I can have let's call this properly. I can have a 3/1/4. This is also a positive number, but it is not a positive integer. Do you understand? Okay, likewise here. If I have something here, -2.3, this is a negative number, but it is not a negative integer. Integer must be whole number. Everybody clear? Okay, I can also have here, -4.5. This is also a negative number. So what does it mean? All numbers on this side are positive, all numbers on this side are negative. If they are whole numbers, we call it integers. If not, they are just numbers. Everybody clear? Okay? Alright, good. Now, next okay? As we have seen in, numbers that are less than 0 are called negative numbers. Now, as we have seen in chapter opener, and the introductory problem, we do encounter negative numbers in real world like negative 80 degrees Celsius, negative 5793 meters. The negative number negative 80 is read as negative 80. Okay, I think you have seen this before, right? In some countries you go to, the temperature is actually below 0 degrees. Okay, so it's negative. I think you go shopping centers before. Put your head up. You go shopping centers before. There's basement, right? Okay, basement 1, basement 2, right? But there's a reference point. Correct? Okay, now for example, you can say land is at 0 level. So the mountain will be positive, right? How about the bottom of the sea? It will be negative. So there's a reference point. Everybody clear? Okay, now let's take a look now. When measuring temperature, 0 degrees Celsius is the reference temperature. Okay, temperatures above 0 degrees Celsius are positive, while temperatures below 0 degrees Celsius are negative. A temperature of negative 80 degrees Celsius means that the temperature is 80 degrees below 0. Understand? Okay, now next. When measuring altitudes, that means heights. Altitude means heights. The sea level is used as a reference level. Heights above the sea level are given positive values, while heights below the sea level are given negative values. Okay? Next, I want to tell you what are absolute values. Absolute values means you don't care about the sign. For example, I ask you all to look at what. What is the absolute value of 4? It's just 4. What's the absolute value of negative 4? It's also 4. Because it's the distance away from the reference point. That's all. Okay, so absolute value do not care about the sign. Everybody clear? So, let me ask you. What's the absolute value of 17? 17, no? What's the absolute value of negative 20? 20, because it's 20 to the left. That's all. Everybody clear with what I'm saying? Okay, now let's look at the next page. That's what they say. Okay. A number is made up of an absolute value with a positive or negative sign in front. The negative number, negative 80, has an absolute value of 80 and a negative sign in front. Are we clear now? Absolute value means the distance away from the reference point. Okay? It doesn't have positive or negative, it's just a number. Okay? Now, we usually write a positive number as positive 80, as 80 without the positive sign. That means when I write like that, that means there's an invisible plus here. Okay, just a don't write plus, very confusing. Okay, but when it is negative, you have to write negative. You cannot say invisible negative, cannot. Okay, invisible plus, yes. No invisible negative. Okay, now next. Okay, in primary schools, we have learned about whole numbers, 0, 1, 2, 3. What about numbers such as negative 1, negative 2, and so on? Together, these numbers are called integers. Can you see? We told you on the board, right? Okay. Now, positive integers are positive whole numbers, while negative integers are negative numbers such as negative of the absolute value. Okay. Now, 0 is neither a positive nor a negative integer. We told you 0 is called what? Neutral integer. Are we all okay so far? Are we all okay so far? Okay, now let us look at practice now 1A, question 1. I want to look at practice now 1A, question 1. Take your pencil. We are going to start on the board. Okay, I'm going to write down the number. 0, 2, 0. This one? Is 0 positive? No. All these are not. What's the next positive integer? 6. Everybody clear? Everybody clear? Positive integer means positive whole number. What about negative integers? Which is the first one? Negative 5. Followed by negative 1. 17. All these are negative integers. Are we okay? Now, what's the difference between part 1 and part 3? These are what? Positive numbers. Now, positive numbers include integers. You don't say numbers don't include integers, it includes. That means integers is special, just that it is a whole number. But all these are called positive numbers. Understand? That means numbers on this side are all called positive numbers, and numbers on this side are all called negative numbers. Just that when it is this type, it is called integers. Are we clear? Okay? Can or cannot? Now, let's take a look here. Positive numbers. What? We start from that. Where? 2, 0, 2, 0. Followed by 1.666. Followed by 3 quarter. Very good. Followed by 6. Everybody okay? Yeah. Alright, do the last one. Negative numbers. What are they? Which one? Negative 5, negative half, negative 3.8, negative 17, negative 5 over 3. Are we clear now? Are we clear now? Okay, I just want to say this for a while, because the next lesson I'm going on to greater, less than, and how to evaluate, how to use a calculator. Are you all clear with me? Are you clear? All of you listen now. This side are all called positive numbers. This side are all called negative numbers. But if it is a whole number, it is called positive one. Integers. Positive numbers include positive integers. But positive integers may not be a positive number. Okay? Because it can be 1.6. You understand what I'm talking about? Can or cannot? These side are all called negative numbers. These are just special ones that are called negative integers. What is 0 called? Neutral. Are we clear? Are we clear? Okay, good. Now, because I will only see you next week, right? Can all of you go back? Can you read page 33? 33 all the way to 44. Just read only.